There are three things we care about in kinematics. What are those three things? Velocity, acceleration, position, right? And in simple harmonic motion, if we have things oscillating, we typically use sines and cosines to describe that oscillation. So in terms of position, I believe we started out typically with cosine omega t, yes? Yeah. A cos omega t, and that looks something like this. If I were to sketch it, this is position versus time. And then velocity ended up being negative a omega sine omega t. And acceleration ended up being what? Minus a omega squared. And those also have sines and cosines to describe how the velocity changes with time and how the acceleration changes with time. So what do you need to know for this problem? You need to be given a set of information to be able to determine, the amplitude, the frequency, the angular frequency, spring constants, those sorts of things. So, somebody tell me what this represents. No, amplitude is this.
Oh, that. Okay. That's distance.
What is this?
X.
Period T. How long does it take for a complete cycle of the object? Does that make sense? So period is the time for one complete cycle. And we know that frequency is 1 over t. How many cycles occur in some period of time is frequency, also known as hertz. You might have heard the term hertz. Car rental agency. Has nothing to do with this. This omega is that guy right there. Yes?
Yep.
What's the maximum velocity at any given time? Maximum velocity.
Is that in the parentheses?
Why? It's the amplitude of the velocity function. Remember, guys, if you have a constant in front of a sine or a cosine, this is the amplitude of that particular function. So this is the amplitude of velocity, this is the amplitude of position, this is the amplitude of acceleration. The maximum possible value it can be. That's true of any sine function, sine or cosine. This constant is the amplitude, whatever that constant is. So what's the maximum acceleration?
It's in the parentheses.
A omega squared. Yeah? What's another way to determine the, for a mass spring system? What's another way to determine the angular frequency, omega, for a mass spring system? What?
2 pi over t?
No, I already told you that. Well, yeah, sure, that's a plug-in. A different way. Gabriel.
Third, spring constant provided
Yes! Omega, remember, in an ideal mass spring system. If I get the strength of the spring just right for a given mass, I can figure out the frequency with which it will oscillate. Angular frequency with which it will oscillate. So, good. The only thing that determines the frequency is how stiff the spring is and how much mass is on the end of it. You guys look like deer in the headlights coming up on that bumper. Yep, that's us. Kenley's like, yep, yep, yep. What else might you need to know?